Hello, everyone. Thank you so much for joining us today for this webinar on the Newcastle Pilgrim Quarter Structural Health Monitoring Project. My name is Ambra, and I work in the marketing department at Move Solutions. For everyone that is new to our webinars, Move Solutions is a company that provides structural health monitoring systems based on Internet of Things technology, with completely wireless sensors for static, dynamic, and environmental analysis. That makes them suited for many different projects in different industries, such as the construction monitoring, which will be the focus of today. If you have any questions during the presentation that you would like to ask us, you can write them in the Q&A box and they will be answered at the end. So with me here today, we have Mark Flo, Sales Manager at Move Solutions, and Mark Anderson, Director at Academy Geomatics. Mark Flo is here to give you a brief overview of our wireless structural health monitoring system, to then leave the floor to Mark Anderson that will go into the details of the Pilgrim Quarter project, where Academy Geomatics installed Move Solutions static and dynamic sensors to monitor different structures during construction works. Academy Geomatics is a land and building survey company based in the northeast of England, offering a full range of services all over the UK. As one of Move Solutions' technical partners in the UK, they provide our clients with an end-to-end support and they guide them during their projects, helping them choose the right structural health monitoring system, sometimes integrating it with other services they offer, such as laser scanning, which was also used for this project, 3D modeling, topographical surveys, and many more. If you're interested in learning more about Solutions technical partners and their services, you can find a dedicated page on our website. So today we will focus on the monitoring project at the Pilgrim Quarter, where construction works have been taking place for what is going to be the biggest office development in Newcastle City Centre history. So Mark will explain what were the structures that needed monitoring and why. What type of sensors were used and what insights on the health of the structures they managed to get. Before going into the details of the project, I will leave the floor to Mark Flo, who will give you a brief overview of the Move Solution system so that you can better understand its application on this project. So, Mark, the floor to you.
Thank you. Hello, and thank you so much, Mark, for attending also this webinar and explaining to us your experience later. So, as Amber introduced me, I'm Mark Flo, Sales Manager for Move Solutions, and I want to briefly introduce you to our company and our solution. And can you see all my screen? Amber?
Yes.
So fine. Okay. First of all, I want to introduce you to Move Solution and let you know who's Move Solution. That's a leading company in the smart structural health monitoring. We provide a wireless monitoring solution for all the civil infrastructures, and we combine static and dynamic monitoring for construction sites, as you can see in the slide, in all the monitoring overview in as different solutions as bridges, railways, different construction sites and infrastructure constructions as dams or tunnels. So we provide the full solution, hardware and software. So Move Solution include a full range of sensors like tiltmeters, accelerometers, vibrometers, deck-specific spatial sensor, different nodes. So the idea is to we work with wireless technology and LoRaWAN protocol. So the idea is to have a very simple plug and play system, very easy to install, and with a low maintenance for the works of monitoring works. So actually, the most important point is the long battery life of our sensors that can last until 8-10 years. About the software part, so we use and we proceed with the data analysis through our Move cloud platform. There is a very friendly user software that allow real-time readings of the structure that we are monitoring with different tools and easy functions that give us real-time monitoring. What is important to remark is the full online management of our monitoring works. We can control all the devices remotely, and it's very important that we set specific alarms in real time, as I mentioned, in 24/7 notifications in case of. I want also to introduce you to our system architecture that we divide in let's say in three different processes. That's the first one is the data acquisition that we install as mentioned before. The sensors are very simple to install. As I mentioned before, a plug and play. So once are installed, they start collecting data and connect to the gateway where we start what we call the data processing. In the data processing from the gateway, we send all the data to our servers where we analyze and process all the collected data from the sensors. After that, we go to the data monitoring. We can see all this information with our tools, functions, and loadings that we use, and we have full data 24/7 and set the alarms needed. I'm sorry, I'm here. Okay, so I want to introduce because I think that this case study that we have today, it's very interesting because we want to show you that Move Solutions is able to offer and monitor different and all surrounding type of monitoring. So we work in different, let's say, divisions or different type of monitoring that we call. We divide our solution and our system in static monitoring, dynamic, and geo-environmental. So I want to briefly talk about it. With static, what we want to work is on reactive monitoring. So we want to measure mostly movement and displacement. We have specific sensors for all of these situations. On dynamic structural health monitoring, what we are looking for is mostly predictive monitoring work. We want to measure the stress of any infrastructure, and we with the control of vibrations, frequencies, or model shapes. On the other side, we are also able to supply geo-environmental solution and monitoring in all situations that is needed with our nodes and a third-party proof. So this allows us to go into what we call a smart construction site monitoring, and we allow acquisition of data in any need of job site and surroundings. So the case of today, it's a clear example of that we not specific going to be focused on a specific part of the job of infrastructure. So we want to understand what's going on all around the job site. We offer a complete monitoring solution, as I mentioned, with static and dynamic, with wireless IoT monitoring beyond our work site. So this is a clear example that we can check and monitoring in real time what's going on around our works. So I would like to let Mark now to give us the best example with this interesting case study.
Right, thank you, Mark. And I'll just share my screen.
Thanks to you, Mark.
Can you see that now?
Yes.
Yes.
So this is a little chat about the static and dynamic monitoring that we've been doing in the centre of Newcastle upon Tyne, up in the north of England. It covers a large area of the city centre that's due for regeneration. It's been gradually bought over quite a few years. So we've been privileged to be involved with some of the monitoring of it. We've actually been working on these sites since the mid-90s. But certainly these jobs have provided some interesting challenges to the monitoring, and hopefully we can give you a flavour of them today. So what is the Pilgrim Quarter? Well, this is Newcastle upon Tyne. There's the mighty Tyne. There's the Theatre of Dreams. The Pilgrim Quarter is in the centre of the city centre. It's about 3 blocks big. Variety of buildings, new builds, very historical old builds, and we've been doing surveys there of all sorts since the mid-90s, floor plans, elevations, all sorts. In terms of monitoring, so this is the northern third. In terms of monitoring, there's 3 elements to it. Firstly is the metro tunnel, which runs through the site here. It's about 16 meters under the surface. The second element, and that's a twin bore metro tunnel. They run every sort of 10 minutes or so. So it's quite a busy thoroughfare. We've got the vent tunnel here. So this is a ventilation stroke pressure overrun tunnel, which comes out the twin bore and surfaces here. That's about 10 meters under the surface. And then later on last year, we were asked about Carliol House, which is a listed facade that they have to support and keep in situ while the back end is knocked out. So we're asked to monitor that as well, seeing as we're already on site. With the metro and the vent tunnel, first things first, we needed to know where the metro tunnel was. We only had as-built drawings to go with, so we conducted a rigorous survey, which you can see here in yellow. That's the metro tunnels, and the purple there is the vent tunnel. The red is the topographical survey that we've conducted many years before, and we'd updated for this project. This allowed us to see where the metro tunnels lay with respect to the surface features, and therefore we could decide which areas need monitored and how rigorous they needed to be, how close they were going to be to the new development, because all this is getting, aside from the facade, is getting completely gutted. As part of the survey work that we did, we also conducted a laser scan survey. So we can see here, we've got the twin bore, the metro tunnels, the little link, and then we've got the vent tunnel coming up to the surface, and this is the ground here, so under the surface. This allowed us to do a number of things. One, it allowed us to complete the survey work, and we were able to map out, all the features that we needed, the rails, all the drainage features, the overhead lines, within the zone of influence, but also with an eye on the monitoring that we had to do. It allowed us to design in full 3D our sort of site and work out whether or not we could use prisms, see if there's enough room between the prisms for the instruments to lock on, and whether or not we'd have to use tilts and things like that. But with the point cloud survey, we could prove that our suggestions were going to be feasible. In this diagram here, we can see where we were planning on putting our toll station, and we could prove that we were the regulation distance away from the kinematic envelope of the trains that we're passing through. So we knew that they'd be safe from being hit or provide any sort of interference. The point cloud actually provides a secondary, well, I can't remember what number on to, but it provides another use in that monitoring, you're tending to to measure on sort of set intervals. So what happens if something happens between it? Well, hopefully whatever you're using to monitor the tunnel width would move, and you'd be able to then revisit the site, laser scan it again, and show in more detail all the elements that have moved or not moved, perhaps. So it's a handy reference point there. But if we move on to the monitoring proposal that we started with, when we were undertaking the survey work, it was fairly straightforward from just being in there how things would work if we were allowed to run with that proposal. The proposal was to install an automated total station within the running tunnel. It was going to be mounted on the emergency walkway. So we weren't too sure until quite late on that we were allowed to use the emergency walkway. If we hadn't been allowed to use it, if they thought we were going to block it too much with the instrument, then we would have used tilt sensors all around. But because we've got another installation about 500 meters to the west of this site with an automated total station, because there's plenty of room there, we kind of felt we had to keep it the same because it was the same methodology and all that. We were going to monitor 18 cross sections. Each cross section would have 5 monitoring prisms on, so 2 at the bottom, 2 at the top, and 1 at the very crown of the tunnel. That would allow us to get fine detail on how things were moving in the cast iron ring sections. 2 CCTV cameras, because when people are working in the tunnel, sometimes they see a shiny prism or tilt sensor and they can't help themselves but touch them. So having the cameras in there allowed us to check that any movement that happened at night was movement or was people interfering with the equipment. A move gateway to talk to all the wireless sensors. In the vent tunnel, because there's no visibility with anything, it's only 25 meters long. That was exclusively move tilt sensors. So 3 cross sections of 3 tilt sensors. We also decided to supplement the static data, the total station monitoring, that's static data, the tilt sensors is static data. We chose to augment that with 4 accelerometers, 2 in each tunnel at either end of the areas in question, to see what interesting information that would give us and give us an idea of whether or not perhaps the backfill on the tunnel had been worn away with the piling activities and things like that. It gives a good structural health idea of the tunnel makeup, really. And we also installed a vibrometer on each of the 2 tunnels, again, to help with the piling, give us an idea if they're piling too close or if they've hit something that's interfering with the metro tunnel, things like that. So the monitoring installation, so a few images from us putting the equipment in. So here's the automated total station, the 2 cameras and the power box and comms box for the total station. This is at the base of the vent tower. So we managed during the survey to find a power point here. So we're using 110-volt power to power all the equipment. In the box, we've got a large battery, backup battery, just in case the power was unreliable. And in the background there, we've got the move gateway there in a protected box, just because it's filthy down there. This is a view of the running tunnel, so you can see the reflections from the flash of the camera on all the prisms facing the way of the instrument. There's a close-up shot of one of the prisms. Prisms were stuck on with really powerful small magnets. It takes a bit of force to get them off. There's a view of the ventilation tunnel. So we've got a tilt sensor, and a tilt sensor, and an accelerometer. Sorry, the vibrometer, that's the central section there. And that's the end of the vent tunnel. So we've got a tilt sensor and an accelerometer there facing the site. This was all installed over the course of 5 frantic night shifts. Typically on the metro system, you only get about 4 to 5 hours per night, depending on what time the last train came in and what time the first train out is. So you don't get a huge amount of time by the time you've pumped all your equipment in. We also required the power to be turned off within the running tunnel for two nights to get the insulated ladder up there and put all the high prisms up there. So yes, a frantic week. In terms of the monitoring results, we have the total station results here, fed in through T4D because we use Trimble instruments and equipment. You can generally see sort of daytime and nighttime. You can tell when the trains aren't running because there's less noise in the data. Our tilt sensor results are, this is a couple of months, it's about 3 months worth of data there. You can see how flat the data is, very, very slight movements in correlation with the temperature, really, which shows that the tunnel is actually, really quite stable and things haven't been affected by the building works. And it's actually quite interesting to see that it's quite bland. The client's happy if the tunnel's not moving. The vibrometer results, again, you can clearly see where night is. All these lower areas on the graph are nighttime, where there's no metro trains running and there's no site work being involved. When we do get an anomalous spike with the alarms triggering from the platform, we can check the CCTV cameras, see if there's a train moving past at that time, or whether or not they were piling on site near the tunnel, and we can work out what the spikes were, thus giving assurance on the structural integrity of the tunnel. The further results from the accelerometers are quite interesting. So the modal analysis, so the accelerometers in the two pairs, after a 2-week learning period, learn the internal frequencies of the structures they're attached to. So this is the results, and the results are actually quite bad, but that actually is quite a good thing. So you can see this, the spurious nature of the line. There's not many data points on there, and you can see it's all over the place. That actually shows it's been really hard for the accelerometers to lock onto a specific frequency within the tunnel. So therefore, it's actually quite a structurally healthy tunnel. It's, the works so far haven't impeded the structural health of the tunnel. If that changes and we're starting to get more data points through or more frequencies picked out, then we know that potentially there's been a problem. We can look at the other data sets to see what's going on. So that's the metro side of things and the vent tunnel. If we have a look at Carliol House now, so this facade is listed. It's a grade 2 listed facade. It's beautiful Portland stone. When you're up close and personal drilling holes in it, you can see all the seashells and stuff. Once it's cleaned up, it'll be a fantastic looking facade. It was actually constructed about the same time as the Tyne Bridge, so that kind of dates it's how long it's been there. We've surveyed this many years ago, before laser scanners and modern tech, but we have updated our survey to be more with the times. So the plan is to knock the back end out of the building to make it more usable in the modern day. So this is the Revit model of the facade of Carliol House that we produced. We did the laser scanning, we did the Revit model, and you can see where the developers have shown their proposed support steels to support the facade during the works, and you can see the back end that has to be taken out. Originally, we were going to use 3-meter tilt beams on the building face, but then with the amount of steel work that was going on, there was no way we were going to be able to thread those through the warren of steel work. So we've had to use 1-meter long tilt beams. Far better to be a tilt beam a bit shorter than you want than not at all. We decided not to use any dynamic sensors on this because any movement we would see in the tilt sensors, and any dynamic movement is kind of irrelevant on this because we don't want any movement at all. So this elevation drawing shows our plan of where we'll mount the tilt beams, 24 tilt beams, top and bottom pairs, 2 on the west face and the rest on the south face. Carefully located, not to interfere with any steel work. There's no sensors at the bottom of the facade because they have filled, I don't know, maybe a meter and a half of concrete on the bottom to form a stable platform to mount their columns on. Phenomenal amount of columns and metalwork. Again, during the installation, we had to do it at night with the street closure and all the workers out the way. Get the access platform up, offer up the tilt beams to the facade, mark the holes, drill the holes, and then anchor them securely with concrete bolts. Quite a job to thread the platform in between all the columns of steel, but the driver was a bit of a wizard, and we got through a bit quicker than expected, I think. The results are quite interesting. So here we have the tilt data going into T4D, and you can see the temperature there, the red line there. And there's always one sensor that moves more than the rest, and you can see it there, very, very strong correlation with the temperature. Within the Move platform, we're looking at the tilt data again, and again, you can see here, and we can see here where they've knocked the tilt beam, you know, putting up their steel work, or perhaps an impact from the internal building work. So we've had a big jump in the data, but it's gone back to where it was, and we can tell that it's just continuing normally. This chart here shows one of the angles, the in and out angle of the top sensor and the bottom sensor. So we can kind of see that actually the two sensors are moving in opposite directions. So the building's sort of flexing a little bit, just very marginal amounts, but it does show that the disparity between the top and bottom movements. So it's touch wood, it's all going well. And there's been no significant movement to date, aside from the guys knocking the tilt beams when they're doing the work. And that's about it, really. I don't know if anybody's got any questions or anything to add.
Thank you so much, Mark,
No problem.
and Mark.
Yeah, of course.
I always find it very interesting to learn about real-life projects and applications of Move solution system. And I was in Newcastle, and I remember the Carliol house, so I can't wait to see it finished and done. So today we have seen a couple of applications of for dynamic and static structural health monitoring in construction. However, if you would like to better understand the different types of monitoring that are important for a more comprehensive approach to structural analysis, you can already sign up to our next webinar on the 8th of June, which will be an event dedicated to the topic. You can see my screen, right?
Correct.
So to register for the event, you can either scan this QR code or check the resources section of our website, where you will find all our webinars, including the recording of this one, because our attendees always ask about it. And the recording will also be sent to you via email and accessible on our YouTube channel. For our next webinar, yes, we will talk about static, dynamic, and environmental monitoring, when these types of monitoring are applied and why. And there will be me with shorter hair and Francesco. Also, yes. Through our website, you can also subscribe to our newsletter if you would like to stay updated on our monthly webinars and new product releases and news in general. Again, you can do it just going to Move Solutions website and clicking on the top right button on the home page, or by scanning this QR code. We like QR codes here at Move Solutions. In general, for more information on the solutions we offer, as well as technical information about our sensors, you can check Move Solutions website, www.movesolutions.it, or send an email to info@movesolutions.it. So I don't know if we have any questions. I don't see any questions popping out. If you have any questions, yes, you can either email us, or if you have specific questions about the Pilgrim Quarter project, you can email Mark Anderson and Academy Geomatics. So if we don't have any questions, that's it then. Thank you both Marks.
Let me let me emphasize that I'm so happy for this presentation of Mark. So I think that's very interesting. The combination of different instruments into the monitoring market. So, and I think that's very important to show to our audience and to the market. So this full combination, it's a fantastic case, I think.
It's
Thank you,
really interesting. Yes. Thank you so much. I don't know if you have anything else to add, Mark Anderson.
No.
See, oh, sorry. Okay. I think that's it then.
Okay.
Okay. Thank you so much, and thank you for everyone who joined us today, and see you at the next one.
Thank you.
Thank you.
Thank you, Mark. Talk to you soon.
No problem.